is, sorry, had my test run there. So we're going to go through transforming functions and then shifting functions. So when we transform the functions, we look at g in terms of y is, I guess that y is the hint there. Anyways, hopefully this is not a glitch, but g in terms of f, all we have is we have a shift down 5. Alright, so our shift should be down 5, and that's just looking at the problem right here. So that's going to be f of x minus 5. So I'm going to check. Is that giving us credit? Okay, so I guess for some reason it started with the hints, so it's not giving us credit, but still, that's the answer, down 5. So I don't know why it started with the hint, so I guess that was a glitch there. Alright. Okay, so what is g in terms of f? Sorry, why is that? Okay, that's not going away. Alright, so the red function in terms of the blue function, what I see is that we have a little bit of shift. Okay, so the shift is going to be right 6. Okay, so when you're going right 6, 1, 2, 3, 4, 5, 6, that's going to be f of x minus 6. Okay, so if you have f of x minus h, and we're going right 6, that means h equals 6, so you have f of x minus 6. So that's the answer. Okay, now we're going to go look at this problem. What is the formula of g in terms of f? So we're looking at horizontally. Looks like g is seriously stretched out compared to f of x, and it also looks like it's probably flipped across the y-axis. So it looks like we might have a y-axis reflection and then we also have a horizontal stretch. So that just means that b is negative, and that the absolute value of b is going to be less than 1, and that's for a f of b, parentheses x minus h plus k. Alright, so that's looking at b there. So b is less than 1 only when it's f of negative 1/3 x. Alright, we got that right. What is the formula of g in terms of f? Well, to me, it looks like the red function just has a vertical stretch relative to the blue function. It seems like to me it seems like it's vertical, not horizontal. It looks like all the horizontal points line up, but vertically you need to stretch. When you do, this value goes from 4 to 8, so it doubles. So that means you have a vertical stretch of 2, and only 2 is the one outside of f of x, and also there's no x-axis flip, so it can't be that negative 2. So these are the only ones with stretch, and it doesn't have an x-axis flip, so it's not going to be c. So it's going to be b and not c. Alright, going on to the next question, if it will allow me to. Okay, so here's what happens when it glitches on you. You hit the refresh button. Alright, now we're on 4 out of 4, so we fix that with the refresh button. Now the last step is the red function relative to the blue function, you're just shifting down 5. So here, k equals negative 5. So we'll have f of x plus k, it's negative 5. So we'll have f of x minus 5. So that's going to be c. Alright, so that's a 100. So now we're going to shift functions, okay? That's transforming functions, now we're shifting functions. So f of x is a transformation of h of x. Given that h of x is negative x minus 1 squared minus 1, write an expression for f of x in terms of x. So that's not in terms of h of x, but that's in terms of x. So let's start things with h of x. So h of x is negative x minus 1 squared minus 1. Now we need to see how f of x is changed from h of x. And all I can really see right now is we have a vertical shift. We go up 1, 2, 3, 4, 5, 6. So we go up 6. So we have negative x minus 1 squared minus 1, and our shift is just up 6. That just means that we do plus 6 for k. So we just add 6 here, and we'll ultimately have negative x minus 1 squared plus 5. That's what our ultimate answer will be. So we'll change that minus 1 to a plus 5 and see what that does for us. Gets it right, that's what it does for us. Now, we have y is equal to g of x and y is equal to h of x. Write the terms of functions h in terms of function g. So we're in terms of function g, so that means that we have to start with g of x. So we start with g of x and we look for the shifts. Well, our shifts are going to be 1, 2, 3, 4, 5, left 5, okay, and then we go up 1. So if we have g of x, we'll have g of x plus 5 plus 1. Because really what we're writing here is a of g times b times x minus h plus k, and we're saying a equals 1, no change, b equals 1, no change, but h is equal to negative 5, because we go left 5, and k equals 1. So we just ignore the a and b, and we have g of x minus negative 5, which is x plus 5, plus k, which is going to be plus 1. So g of x plus 5 plus 1. Got it right. Okay, so that's, think about it in terms of this function notation right here. Next question, which is the following of the graph? We have the square root of x. Now we need the square root of x plus 1, so that all that's going to do is left shift. And if we're getting really specific and technical, we're factoring out the 1, so we have the square root of comma 1 of x plus 1. So we're going to the left by 1, and so this is the only answer where we go to the left by 1. Got that right. Okay. This one's a little bit more tricky. So we have negative 1/4 x squared is shown below. The g of x is negative 1/4 x plus 3 squared. So the original function should match the old function, except for that we have a shift 3. So let's go from 5, 5 to 5, 5, negative 5, wait. Oh, sorry, here, what we want to do is we want to go to, let's see, 2, okay, wait, there we go. Alright, we go to 4, negative 4, okay. And then we're shifting x plus 3 squared, which means that's going to be left 3, so left 3. So when we go left 3, we go 1, 2, 3. And then that means this value also going to go 1, 2, 3. So that should look the same. So let's check. Excellent. Okay. So be careful here. When you shift, first you have to make it match this graph, and then just look at the transformations. Make sure that when you shift the vertex, you're also shifting this other point right here. Okay, so that's the tutorial. Thank you, and have a great Sunday.